So today, lecture number 16, it's very important for the final exam. We are going to learn a new thing, no relation between today's lecture and the previous one. Today's lecture covers section 7.1 from the textbook, and we are going to learn the Laplace transform. Here are the objectives of our lecture. The aim of Laplace transform is to solve some initial value problems or some differential equations. So in this diagram, you will understand the procedure of using Laplace transform. So I have differential equation with the unknown yt. I'm going to apply Laplace transform to my differential equation to get algebraic equation in y capital of S. So the new unknown, it is y capital of S, not y of t. I'm going to solve this algebraic equation in terms of y capital of S, then take inverse Laplace to find the solution of your differential equation y of t. I know that you can't understand now this diagram because we didn't start studying the Laplace transform. So let me, first of all, introduce the definition of Laplace transform. First of all, don't forget, don't worry about the word transform, because the word transform is similar to the word operator. Do you remember the operator d of y is what? Do you remember d of y is what?
Derivative of y.
A derivative of y. So y prime or dy over dx. You are right. dy over dx. So this is an operator, or I can call it transform. Also, by the way, a new transform or a new operator which you didn't study and no need for it, I of y or I of f, I of f. That means in mathematics you need to find the integral of your function f of x times dx. So those are operators or transform. Today we are going to study the Laplace operator or transform. Here the definition. If I have a function f and my function defined for all positive values for t, then the Laplace operator, which has this notation L capital, Laplace transform of my function f of t, like those brackets, you need to write those brackets, okay, is equal by definition to the integral, don't forget that your limit from 0 to infinity, of the exponential function with the power negative st times my function, my given function f of t. So for me, I think it's very easy. If you give me any function f and you need me to find its Laplace transform, I'm going to take the integral of my function multiplied by exponential negative st starting from 0 to infinity. Now, if this answer is finite number, so it is m finite number, and at that time this integral is converges, then I will call my answer Laplace transform of the function f. I will repeat, after evaluating this integral, if you get a specific finite number, so you will say that this integral is finite, or this integral is converges, and at that time this answer is the Laplace transform of this function. But if this answer isn't finite and your integral isn't converges, so no Laplace for the function f. So the condition for finding or existing the Laplace transform of any specific function is to evaluate this integral to get finite number. That means your integral is converges. But if the integral isn't converges, so no Laplace transform at all. Let us try to find the Laplace transform of those functions. Read here the question. Find Laplace transform and state its domain region of convergence. Let us try to find the first one, Laplace of number 1. Let me use the yellow here. So I'm going to use this pen. So first of all, I need to find Laplace of the function 1. For me, I remember that Laplace, it is an operator. which defined by the following formula, integral from 0 to infinity, my function 1 times exponential e to the negative st dt. This is the definition of Laplace transform. Now I'm going to find this answer equal. So it is integral of e to the negative st only. No need to number 1 dt. How to find this integral? Do you remember? Integral of exponential function.
We divide by the coefficient of the
Great.
t.
We will divide by coefficient of t, so it will be e to the negative st, all divided by negative s. Don't forget your boundaries from 0 to infinity. Equal, let us plug in infinity and then 0 as you do usual. So e to the negative s times infinity divided negative s, I'm sorry. So the integration with respect to t, Professor, what about of this s? It is the parameter, it is a constant, don't care about s. Minus e to the negative s0 divided by negative s. Now I have a question. What do you think about this amount? What do you think about this e to the negative s infinity? It is what?
0.
0. Who said 0? Mera? Who said 0?
Yes, Amir.
Yeah. Why it is 0?
Because it's e to the power negative infinity, so it's 0.
Yes, I understand. Yeah. What do you think if my s is negative 1? Because s is a number. So if my s is negative 1, so you have e to the negative, so it is plus infinity, and this one it is infinity. So I can't decide that this answer is 0 unless if you use a specific condition for s. And by the way, by asking this question, find Laplace transform, that means I need to use specific condition for s to get finite number. That means your integral is converges. So what do you think the condition which I need to use for s? What do you think? To make this exponential finite number, I don't need to use it to be infinity. Can anyone help? The condition which I need to make my integral finite number isn't infinity. And the condition with respect to s.
S greater than 0?
S greater than 0, you are right. S greater than 0. If my s greater than 0, so here I have e to the negative infinity and it is 0. So under this condition, your integral is converges, and that means you can find Laplace transform. Okay, let me write my answers now in yellow. So equal, if the s greater than 0, I have 0 divided negative s. Here negative and negative, it is plus e. E to the 0, it is 1, I'm sorry, 1 over s. So it is 1 over s. You can memorize that Laplace of number 1, it is 1 over s under this condition. And this condition give me the domain. He asking me to find the domain of my function. So s must be greater than 0. Okay, let me solve second example now. So 2, I need you to find Laplace of t. Let me ask Mohammed Jbeili.
Yes,
So
Doc.
you have to apply the rule of Laplace transform. Do you remember the rule of Laplace transform? It is the integral.
I'm not sure.
Yeah, so the same to this one. The rule of Laplace transform, it is integral from 0 to infinity. My function, it is t times it isn't t squared. Why I wrote here squared? My function, it is given to be t here, so no need to t squared. So t, and you will multiply it by exponential negative st dt. So it's a rule. Integrate from 0 to infinity. The integrand function, it is the given one times exponential negative st. Yes, Muhammad. Do you know how to find this, the value of this integral? How to evaluate this integral? Yes.
It's e to the power negative s.
No.
No, sorry.
Don't forget, s is constant, t is your variable.
Yes.
And you need to integrate this function.
So product rule or
Product rule, for integration, actually for me, I don't remember the product rule for integration. Maybe I don't have, I'm not sure. Is there any product rule for integration? I'm not sure. What do you think? How to integrate this function? Remember, please. It's very easy, by the way.
By parts.
By parts, yes. If I have a product between two functions and no relation at all between those two functions, so I'm going to do integration by parts. To do integration by parts, you need to choose one of them to be u and the second one to be dv. Usually, I will take u, the simple function which can simplify my integral. So I'm going to choose the t to be u. So du equal du equal dt. And I'm going to choose e to the negative st with dt. Those both are dv. So the v that will give me my v, it is e to the negative st, as Islam said, divided negative s. And the rule of integration by part, do you remember, Jibeli, the rule of integration by part? Do you remember the rule?
Yes, u times dv
U times dv minus?
minus
Yes? Minus what?
integration v du.
V du. Video, as some students said. So now I'm going to plug in my u, v, dv, du. So here, equal. Yes, sir.
Isn't that the product rule ولا متهيألي? Doesn't that?
So do you mean we call it sometimes the product rule?
Yes.
I'm not sure. Actually, I know it as, by the way, you are right. I can conclude this integration by parts from a product rule of the differentiation. You are right. But usually we call it integration by parts. And for the differentiation, we call it a product rule.
Okay, sorry.
Okay.
Thank you.
Yes, no problem at all. My aim is to know how to integrate this one in the exam. Okay. Now, equal. My v, it is e to the negative st divided negative s times, I think it is v du. It is v du, or what do you think? This one is right?
It's u dv.
U dv. Yes, u dv. So this one is wrong. Let me clean this one. Just 1 minute. I'm going to erase this. It is u dv. 1 minute. Where is my u? My u, it is t times dv, it is e to the negative st, e to the negative st divided negative s from 0 to infinity, minus the integral of your v, which is e to the negative st divided by negative s times your du, it is dt. I'm so sorry. It is dt. Maybe the vaccine, yeah, I'm sorry. So let us now, yeah, here I have limit, and don't forget this, from 0 to infinity. I'm going to take negative s here outside, and I'm going to take e to the negative st down. So I have here the following, 1 over negative s, t over e to the st, am I right? From 0 to infinity, plus 1 over s integral from 0 to infinity e to the negative st dt equal. What do you think about this one? Let us plug in infinity and check the limit. So I'm sorry to this writing. So negative 1 over s, it is here infinity divided e to the infinity. Am I right here? Minus 0 divided e to the 0. This is the first one, plus 1 over s. We are going to find those answers. Here the integral, it will be It will be, I'm sorry, it will be,
Oh, doctor, there's something
Yes.
wrong with the integration. It's UV minus integration V du.
yeah, I wrote here V du.
No, I mean the UdV.
UV, I'm so sorry.
It's UV, yes.
I'm sorry. هو
okay.
الفاكسين ممكن عمل فيني حاجة. آسف.
It's okay.
Sorry. So it is UV. I'm so sorry, let me write it in red to know it is wrong. So it is UV minus integral V du. Maybe Islam said it correctly, but I wrote something wrong. So UV, so it is UV. Where is my U? It is T. And my V, this is V. So right. So only the rule is wrong. So here minus, what about of this integral? As Islam said, if I need to integrate exponential, only divide by coefficient of s. So it is e to the negative st divided by negative s from 0 to infinity. Now I have some questions. Infinity divided e to the infinity. Infinity divided e to the infinity is what?
1.
No, unfortunately no. Muhammad, no, it isn't one.
Indeterminate.
Yes, I can say it. I can say it is indeterminate. But how to determine its value?
Doctor, I think it's 1.
No, it isn't one. Who said one now?
Yusuf al-Nahri.
Yusuf. Why it is one? And Muhammad said it is one. Why is this? This is one. Why?
Because infinity and power infinity will approach infinity, so infinity over infinity 1.
Yes, great. So Muhammad and Yusuf said infinity over infinity. Don't write the white. It is one. Let me check. For me, I know those rules. Infinity divided any number. Infinity divided any number, it will be what? Do you remember? Infinity divided any number?
Infinity.
Infinity. And also I know the following rule. Any number, any specific number divided infinity, it will be what?
0.
Zero. So now, for me, I have two answers here. If I see infinity up, so my answer is infinity. If I see my infinity down, so my answer is 0. Unfortunately, I have two different numbers. So I can't decide which one I have to use. So I call it undetermined. I can't specify my answer. So infinity over infinity, I can't determine the answer. So what should I do? It isn't one at all. Only b divided b, a specific numbers, yes, those are one. But if it is infinity, and also, by the way, let me write here also, third case, as Yusuf and Muhammad suggest, if I have up and down the same, so my answer is 1. So I have 3 different answers. So I can't decide which one I have to use now. Okay? So what you usually do to determine this value of this limit? What do you think? It's very easy, by the way. If you have t over e to the t, when your t tends to infinity, so you have here infinity over infinity. How we can find this value? How we can determine this limit? Do you remember?
Divide by t.
L'Hopital rule. Find differentiation up and differentiation down. So it will be 1 over e to the t. Take now when t tends to infinity. If the t tends to infinity, you have 1 over infinity. 1 over infinity is what? 1 over infinity? 0. So the answer of this, it is 0. And also for me, look what I know. From this here, from this. Up, I have t. Down, I have e to the t. Which one of those functions, the t, which is my numerator, and the e to the t, it is my denominator, is faster and will arrive to infinity first? Who will arrive to infinity first? The numerator or denominator? The
E
exponential
to the
function.
t.
E to the t is
Yeah.
very fast, so it will arrive to infinity first. So my denominator will be infinity first, so my answer is 0. Okay, or you can find this limit using the L'Hopital rule. Let me continue. So here equal, I'm going to write here negative 1 over s. The first one, it is 0, minus, also here 0 divided 1, it is 0, plus 1 over s, here open bracket, e to the negative s infinity, divided negative s, minus e to the negative s0 divided negative s. Those are 0, no need to write them again. So here I have 1 over s bracket. What do you think about this? The first term in my bracket. This is what? Yes, what do you think about this? Is it infinity or 0? What about if your s is negative 1 or negative 2? What do you think if your s is negative? That means you have e to the plus infinity. And e to the plus infinity, it is infinity. And at that time, unfortunately, your integral is diverges, not converges. So no Laplace transform. So your condition also now that s must be greater than 0. So you need to determine the domain by choosing the s. Okay? Is it clear now why do I need my s to be greater than 0? So if s greater than 0, so I have 0 divided negative s, minus or plus, because I have two negatives, e to the 0, it is 1 over s. Now this term will be cancelled out, so you have 1 over s squared. Notice now this is the second rule. 1 over s squared, it is Laplace of t. Okay, let me go to the third one. Maybe I'm not going to do the third one in details, but let us discuss together how to find it. So I need now to find Laplace transform of t squared. It is the rule Laplace is given to be integral from 0 to infinity. My function times the exponential 1 e to the negative st dt. What do you think about this integral? How to find this integral? Who can help now?
Yeah, still by parts.
You still by parts. How many times do you need to use by parts now?
3 times.
No, only 2 times because you have t squared. So notice here for t, you used only 1 time. For t squared, you need 2 times. Okay, so I'm going to choose this to be u and this to be dv. And you will apply by parts twice. You will get the final answer to be 2 divided s to the power 3. This is the final answer. Please try to do the integration by parts twice and you have to get the same answer. By the way, this one, it is a rule, which I'm going to summarize here, all the rules. I'm not sure if I have more problems here. What do you think? Yeah, before explaining the rules, let me do the Laplace of e to the negative 3t and cosine 2t. So I need here also to find Laplace of e to the negative 3t. Let me choose, sorry, but I need the students to participate. That will help to understand more. Ahmed Nikrashi. Ahmed here? Yes, Ahmed. So how to find Laplace of any function? Do you remember the rule? Ahmed? So Mohamed Zamil? Mohamed Zamil? Marwan Shawqi? Marwan here? So Yusuf Nihrari. Yes, Yusuf, ready? Can you hear me? Anyone
Yes,
here?
I'm here.
Yes.
But I don't think I can solve it.
No, it's very easy, don't worry.
Yes.
Only you have to remember the definition of Laplace transform is given to be integral from 0 to infinity. Your function times exponential e to the negative st dt. Now how to find this integral? Do you remember how to find this integral?
No, to be honest.
It's very easy. If you have a product between two exponentials, so what should I do? So do you remember that if I have a to the power n times a to the power m, this is given to be what? Do you remember?
8 to the power nm.
A to the power n nm, or what do you mean?
N times m.
No,
N plus
Yes.
m, sorry. N plus m.
n plus m. Yes, so it is a to the power n plus m. No problem, Marwan. So now I'm going to write as you applied this rule. So it is integral from 0 to infinity e to the negative st negative 3t dt. Any simplification step, please, Yusuf?
I can take a t common factor.
Great. From 0 to infinity e to the t negative s negative 3 dt. Now, this is integral of exponential function. The coefficients of your t, it is this term, negative s, negative 3. So as Islam said, only take your function, e to the t, negative s, negative 3, all divide by coefficient of your t. So it is negative s, negative 3. Don't forget your limits from 0 to infinity. I'm going to plug in infinity and 0. So it is e to the infinity times negative s negative 3, all divided negative s negative 3, minus e to the 0 times anything negative s negative 3, all divided by negative s negative 3, equal. What about of the first one? I need some help. Anyone, please? How to evaluate the first limit here such that you need your answer to be finite. Yes, who is
It would be
speaking?
e to the infinity only.
Yes, e to the infinity. It is, my question, is it a plus infinity or minus infinity? This is my question. Plus or minus infinity? What do you think, Yusuf?
It could be positive infinity if s is greater than
Yes. Greater than what? You are right.
if s is greater than negative 3.
Yes. So my aim, notice, Yusuf,
And
my aim is to let
if s is greater than negative,
yeah, I'm going to write what you said. Yes, great, Yusuf. So you need to discuss if this negative is negative 3 positive or negative. My aim is to let it negative because I need e to the negative infinity to get 0. But if you have e to the infinity, so you will get infinity. And at that time, your integral is diverges and no Laplace transform. So I need this one to be less than 0. Move s here. So negative 3 less than s. Your s must greater than negative 3 to get converges integral. Okay, let us continue now. In this condition, when s greater than negative 3, I have this limit with the infinity to be 0. Now, minus and minus here, so it would be plus. And e to the 0 is 1, so it is plus 1 over s plus 3. It is a rule. Laplace e to the negative 3 is given by this. Now, in the coming slide, I'm going to explain all the rules. Yes, thank you. Now, let me solve the cosine 2t. So this is the problem number 3. I'm so sorry. This is problem number 3. And here problem number 4. Okay. Laplace of cosine 2t. For me, I remember the rule of Laplace. It is given to be integral from 0 to infinity. My function cosine 2t time is from my mind the exponential negative st dt. How to find this integral? I need some help now. Really, it's very difficult for me. For those who got A in calculus 2, how to find this integral? What do you think?
It's a product of two functions. So,
Yes, it is a product between two functions. Yes, continue.
So it's UV dash plus.
Yes, so it is a product between two functions and no relation between those two functions. So I'm going to integrate it using integration by parts. So let me call, which one do you prefer to choose to be U and which one to be dV? What do you think?
U could be cosine 2t.
So this is my U and this is my dV. So the du now, it is derivative of cosine 2t, it is negative 2 sine 2t. And here from this, I can find the v to be e to the negative st divided negative s. Am I right here? And the rule said I need u times v minus integral of video. Now, before I continue, can anyone of you guess the following steps to the end of this problem? Can anyone of you remember similar to those problems? No one. No problem. Let us continue. I'm not going to.
The integral will be similar to the first one.
Yes, you are right. So after integration, if, applying the integration by part twice, you will get the same original integral. Let me continue here. I'm going to use the yellow. I'm sorry. So equal. My u, it is cosine 2t, times my v, it is e to the negative st divided negative s. Don't forget the limit from 0 to infinity, minus integral from 0 to infinity of v, which is e to the negative st divided negative s, times my du, it is negative 2 sine 2t all dt. Now I'm going to plug in the infinity, and don't forget, yes, let us plug in infinity. So I have cosine to infinity is cosine infinity, e to the negative. What do you think? Let me take the negative down, the exponential. I'm so sorry. Let me write in a simple way before, then I'm going to continue. So it is cosine negative 1 over s cosine 2t divided e to the st from 0 to infinity. Here, how many minus do I have? 1, 2, 3, so it's negative. Take 2 common, take 2 out the integral, and s is a constant also, from 0 to infinity of e to the negative st sine 2t dt equal. Together, please, here, I'm going to find this limit. So help me to find this limit for infinity, if t infinity. So here you have, let me write. I'm sorry also to write like this. So it is cosine infinity divided e to the infinity minus cosine 0 divided e to the 0. Am I right here? I'm going to continue writing, but let us discuss this. Cosine infinity divided infinity. Do you know the value of cosine infinity? Do you know the value of cosine infinity? So I need the answer of this. I need the answer of this limit. Cosine infinity divided. Yes, Muhammad.
It's supposed to be like fluctuating, and there's no specific answer.
Yes, no specific answer for cosine infinity, you are right?
Yes.
So this limit, this fraction, has a value equal to what?
0.
0. Why it is 0? Great, but why it is 0?
Because it's gonna be like a number over infinity. E to the power of infinity is infinity.
Great, Muhammad. So Muhammad said, Professor, I know that this infinity in the interval from -1 into 1, it is constant, finite constant in this interval from -1 into 1, but I can't determine which value. Okay. divided e to the infinity. This one, it's infinity. So you have number between -1 into 1 divided infinity. So you have number divided infinity, it's 0. Okay, great. What about of this one? Cosine 0 divided e to the 0. Cosine the 0 is what? Do you know the cosine 0?
1.
1 divided 1. Okay. I'm going to continue with this integral. So what about of this integral? How to find this integral? By part also. You need to integrate this one by parts. So I'm going to use, if you use the exponential to be dv, also here you need to use the exponential to be dv. The same. And now my sine 2t, it is u. This is my u. So my du, it is 2 cosine 2t. So the integral using the same rule. I'm going to write it here. Okay, the yellow. So here you have -2 over s. Don't forget, open bracket to write the integrals. So u times v, u times v. So it is sine 2t times v e to the -st divided -s from 0 to infinity minus integral. From integral, this one, it is integral, I'm sorry, from 0 to infinity of your v, which is the exponential e to the -st divided -s times your du. My du, it is 2 cosine 2t. Okay, and here I have dt. I'm sorry because I don't have space. Now let us continue here. So here you have -s. Here I have -2 over s. How to evaluate this? Let us try also to evaluate this. So open a bracket here. First of all, I have 1 over -s. 1 over -s. It is sine 2t. It is sine infinity divided e to the infinity minus sine 0 divided e to the 0. Any question here? Minus, here notice you have minus and minus, so it will be plus. Take 2 and s as a common factor, not common factor, constant. Integral from 0 to infinity, e to the -st, cosine 2t. Cosine 2t dt. Now let us together try to find the answers of those. So equal here, I'm sorry to write here. Here negative times negative, so it is 1 over s. What do you think about this? Sine infinity divided infinity, as Muhammad Jibeli said, it's number divided infinity, it's 0. And also here, sine 0, 0. So 0 divide any number is 0. So all this bracket will be cancelled out. So I have -2 over s, 2 over s bracket. Here I have 2 over s. What about of this integral? How to do this integral? Last integral, how to do it? This one.
By parts also.
If you do this one by parts, so you will spend your time doing integration by part. Here you have cosine. In doing integration by part, you will get sine. Doing integration by part, you will get cosine, sine, cosine, sine. But I think David said, after doing integration by part 2 times, this is the first and this is the second, I will get the same function, the same integral. Notice the function here in white, in this circle white, and this is the same. So let me call this I. So this one is also I. So I'm going to write 2 over s. Instead of all this integral, I'm going to write I. So now what I have, that I equal 1 over s minus 4 over s squared I. Am I right here? I need the I. So let me move all those here. So I will get I plus 4 over s squared I equal 1 over s. Now what I'm going to do, What I'm going to do now is here, can I make, take I common factor first of all. So I common factor. So I have 1 over 1 plus 4 over s squared equal 1 over s. Can I write those? Can I write those with the same denominator? Can anyone help to write with the same denominator? So you'll multiply here by s squared, okay? And here by 1. So I have I bracket s squared plus 4 divided by s squared equal 1 over s. Can anyone give me the value of I now? You will take, Professor, you will take this up, s squared up, and s squared plus 4 down. So the I is what? Can anyone help? Give me the final answer, please. Take s squared up and cancel out with one of those s. So here s. Take this down, so it is s squared plus 4. Also, this is the rule of Laplace of cosine 2t. So you need to remember how to integrate, and you need to remember how to evaluate some limits. Any question here? Or can I go to the rules? No questions? So let me now go to slide in which I summarize the rules which you need to add to your cheat sheet, but not now, for the final exam. Here are the rules. Laplace of number 1, it is 1 over s. Laplace of t to the power n is given by this rule. Okay, and so on. All those are rules. Notice now, before I give you some examples, that here, for the sine k, you take the k up. But for cosine k, no. You have to write up s, the same denominator. What about of shine? The difference between sine and shine only does plus or minus. And also the difference between cosine and cosine, the plus and minus. Those are the rules. I advise now you to take a photo of this slide. I need it to solve the coming problems. But let me give you some examples, some easy examples here. If I ask you to give me the Laplace transform, let me ask about Laplace of t to the power 3. Can anyone help me, please? Please turn on, unmute yourself and answer. T to the power 3 is what? Using this rule.
3 factorial over
3 factorial over what?
s power 4.
S to the power 4. Only you need to apply the rule. What do you mean by factorial, David?
Yeah, 1 times 2 times 3.
Yes, 3 times 2 times 1. You are right. What do you think now? I need another one to help to find e to the negative 4t using the rule. So if I didn't ask you to use the definition which is given to be an integral, you can use those rules. What do you think about this function? Can anyone help? Apply this rule, please.
It will be 1 over s plus 4.
S plus 4. So it's very easy, I think, for you. So take a photo. We need this slide in the coming problems. Any question now? Let me go to solve some problems. Before that, let me explain the linearity probability. And I'm going to use the linearity probability to solve some problems. Do you remember that if I ask you to find the derivative of f plus g, how to find this derivative? And also the integral of tf 2f plus 3g. Do you remember how to find this integral or the derivatives? First derivative, how to find it? A derivative of the first and the derivative of the second. We call this probability linearity. And also here, how to integrate this? You will take 2 out of the integral and the integral of the first f dx. Plus 3 integral of the second g dx. We call this probability linearity probability. Also, Laplace transform satisfy the linearity probability. I will take the number outside and Laplace of the first. Number outside, Laplace of the second function. Linearity probability. Now I need you to use this linearity probability to find the Laplace of the following functions: cosine and cosine squared. By the way, cosine is written in my table in the previous slide, but I need you now to prove it. And the cosine squared, it isn't written. So what we should do for this one? Now I'm going to black slide and let us together find the cosine first of all. So I need to find the cosine of t, Laplace of cosine t. Anyhow, please suggest any idea. What do you think?
ذكر مش الكوشاين ليها رول اصلا.
Yes. Do you remember the rule? Cosine t is given to be what?
S over S square.
No, David, I need you to prove this rule. I need you to prove this rule now. Which is S
do the
over S
integration?
squared. Yes, I can do by integration, you are right. But how to integrate the cosine? So let me write what David said here, but I'm not going to do that. David said, yes, doctor, take the integral from 0 to infinity e to the negative st times cosine t dt. How to integrate this function?
نفك الكوشاين اللي هي e باور
Yes.
نيجاتيف t.
Yeah, you are right. You are right. So you can do that. For me, I'm going to use this identity, the definition of cosine, before I start solving my problem. So the cosine, I remember. Do you remember the rule of cosine, David?
e باور نيجاتيف t.
Yes. E to the power negative t, no? Continue. Maybe you are right. Continue.
e باور t
Yes?
minus e باور نيجاتيف t.
What do you think it is e to the negative t plus e to the negative t?
Plus.
Okay? So it is e to the t plus e to the negative t. Now, if he asked me to find Laplace of f of t, the given function, I'm going to use Laplace of this linear expression, half e to the t plus e to the negative t. And Laplace is linear operator, so take half outside and write Laplace of the first function, which is now e to the t, plus Laplace of the second function, which is now e to the negative t, equal. The half is constant, don't care about it. Do you remember the rule of Laplace e to the t? Do you remember Laplace e to the t? Or do you want me to go back? Please check
1 over
1
s minus
over
1.
S minus 1. It's a rule. Plus 1 over, it is S plus
s plus 1.
Yeah. Now, if I need to simplify this, so I'm going to multiply here by S plus 1, and here multiply by S minus 1. Up and up. So equal half bracket S plus 1 plus S minus 1 divided S plus 1 times S minus 1. Any question here? So equal half. 1 and 1 cancel out. S and S, it is 2S divided. How to write my denominator? Your denominator.
S squared minus 1.
Great. I have this difference between 2 squared. So equal here. This is my bracket. I'm so sorry. It is S squared minus 1. Cancel out 2 is 2. So you have S divided S squared minus 1. Similar to our rule. Let me go to the second problem. GT equal cosine squared t. Do you have any rule in your table to find Laplace of cosine squared t? No. The rule only cosine t. So what should I do? I will integrate. Yes, you can integrate the cosine squared times exponential. It is very difficult from 0 to infinity. So what should I do? Can I convert?
Double angle?
Yes, double angle. So do you remember the rule of the double angle? Anyone
Half
remember?
times 1 plus cosine 2t.
1 plus cosine 2t. You are right. So now, if you need to find Laplace of gt, that means you need to find Laplace of number times summation between two functions. Equal, take the half outside of the Laplace transform, and now find the Laplace of the first function plus the Laplace of the second function. Check your table, please. Do you have the rule for number 1? Laplace of number 1 is given to be what?
1 over s.
1 over s plus Laplace of cosine 2t. Help me, please. Your table. Your table, cosine 2t.
S over S squared plus
S
4.
squared plus 4. So you need to take a photo of the table. I'm going back because I'm sure that maybe 10 students didn't take a photo of this table. Take a photo, please. We need this slide or screenshot or write the rules as you need. Now, I'm going to find the Laplace transform of this function. Professor, where is your function? My function is drawn here. Let me explain it more. Notice now that your function has three values. The first value, if your t less than a, so you are here, the value of your function, it is 0. But if your t between a and b, so the value of your function, it is c. It is c here. And if your t greater than b, the value of your function, it is 0 given here. And I need to find the Laplace transform of this function. So here in this slide, let me write, before finding Laplace transform, let me write the expression or the analytic form of my function. So my f of t now is given by 3 values. It is piecewise continuous function. First one, when the t less than a. Second one, when my t between a and b. Third one, when my t greater than b. No need to equal, greater than b. If t less than a, my function is 0. If t between a and b, my function is c. If t greater than b, my function is 0. I have piecewise continuous function with the 3 values. Now I need you to find the value of Laplace transform. So I need you to find Laplace of f of t. Can anyone help? Can anyone help? It's very easy. I know the rule. Look, can you find this f in your table? The photo which you take now? No. So if you don't have, you have to write the form of your function similar to the tables. Unfortunately, I can't do that. So you have, after that, you have to take the definition of Laplace transform. Definition of Laplace transform is given to be the integral, from 0 to infinity, my function f of t times exponential function e to the negative st dt. Now, you have to plug in the value of ft. Which one should I use? What do you think? The value of your ft now is what? Can anyone help? Which value of ft should I use now?
I should get it for each domain.
Yes. So to do that, what should I do? I'm going to yes. I'm going to split my integral or separate my integrals into 3 integrals. So I'm going to split from 0 to a plus from a to b plus from b to infinity. From 0 to a, I have e to the negative st times from 0 to a. Where is your function? What is your function from 0 to a?
0.
0 dt. Plus from a to b, you have the exponential times. Where is your function from a to b?
C.
C dt. Great. Last one, e to the negative st, and also from b to infinity, you have here the value of function to be 0 dt. So this one is 0, this one is 0. I have only the middle integral, so I have c, the constant, don't care about it, and here exponential as usual, e to the negative st divided by negative s from a to b. I'm going to plug in, so c over negative s, e to the negative sb minus e to the negative sa. Do we need any condition for s, or no need for any condition? The integral will be always converges. What do you think? Do we need some conditions for s?
No need.
No need. What do you think, David, about this
ممكن نقول
denominator?
not zero.
So you can't choose the s to be 0. This is my condition now. So the condition on S, or the condition for S, depend on the form of your function. Not necessarily greater than 0, not necessarily greater than -3, not necessarily not equal 0. That depends on the problem. Okay, and this is my answer, the Laplace of this function. Any question? No questions. Now, the difficult thing that if I give you any function from my mind, I have a question. For this function, can I find its Laplace transform? So for me, if you give me any function and you ask me to find its derivative, I have to check if this function satisfies the condition of differentiation. Okay. Also now, if I give you a function, can you find its Laplace transform or no? We have to satisfy some conditions to guarantee that there is really Laplace transform for this function. So the existence problem, usually, if you have any function and you try to find this integral, if you get here specific number, so you will say this is Laplace transform. But unfortunately, if you get divergence integral or not convergence integral, so here you have the answer infinity, so you will say no Laplace transform. Can I decide that the given function f of t has Laplace transform or no before finding this integral or no? Here the aim of this slide. So here, maybe this example, you have to check if I can find finite answer for the integral or no. The important question, when does the Laplace transform exist? So I have a function and I need to check two conditions to decide that this function has Laplace transform. Okay. Before we study the theorem, which will help me to check if this function, the given function, has Laplace transform, let me introduce the definition of the piecewise continuous function. By the way, I think all of you know that this function, notice this function here, so I'm going to draw this one, it is continuous function. But this function, look to this function, this one, this function, it isn't continuous. So I think all of you can understand easily what is the difference between continuous and discontinuous function. Now let me speak about this one. Notice now this function has only one point in which I have discontinuity. Also, look to this function. So this function continuous. This function isn't continuous. This function isn't continuous. I'm not sure if anyone of you know the difference between those, between this and this. Both of them are not continuous at one point. But I think here, notice this one go to infinity. Do you remember that we call this one, because here I have only small jump, so I call this finite discontinuity. But here, because the jump is infinity, so I call it infinite discontinuity. So here we call it jump discontinuity or finite discontinuity. We call this one infinite discontinuity. Okay. Now, those two are discontinuous functions, but the first one, this one, is piecewise. Why this one is piecewise? Because the number of discontinuous points is finite, and the kind of discontinuity is jump is finite. Now, what about of this? This function, it isn't piecewise continuous function. Why? Because the kind of discontinuity is finite. Sorry, it is infinite. There is infinite jump. So this function, it isn't piecewise, but this one is piecewise. What about of this? Actually, this function also piecewise, because the number of discontinuity points here, only 3 I have. So the number of discontinuity points is finite, and all the discontinuity is finite discontinuities also. So here the definition, we say that function is piecewise if in every finite interval, if the finitely points, I have only finitely points, has finite discontinuities. Okay? Did you get the idea?
Yes.
Yeah. Now let me also introduce the definition of exponential order function. Here the definition. Those two definitions, I need them to introduce the theorem which will help me to decide if my function has Laplace transform only. I can't say or not. Now the exponential order function. If you have a function f, you can say that this function of exponential order, if the following condition is satisfied, such that c, m, t are constants, and the absolute value of your function less than my constant m and c times et, the exponential function. Actually, for me, using this definition is difficult to check if the function of exponential order or no. Instead of using this exponential, I'm going to use the following rule. So starting from now, to check if your function of exponential order or no, please use this limit. Your function divided exponential ct when t tends to infinity, and find the answer. If this answer is finite, so you will say my function of exponential order. If the answer is infinite, so your function not of exponential order. Let me check and study with you those functions. I'm going to do the first three, and you will do the last one, okay? So the first function, the first function, it was, I need the pen. What is the pen? So first function, it was, I think, e to the t squared. So you need to check if e to the t squared of exponential order or no. So you have to take the limit of your function divided e to the ct when t tends to infinity. And you have to decide if this limit is finite or no. What do you think? How to find this limit? I need some help now. What do you think? Should I plug in infinity? So I have e to the infinity divided divided e to the infinity, and it is infinity over infinity. It is undetermined. I can't decide the answer. So what should I do? I need some help.
Can I say e to the power t squared minus ct?
Yeah, great. So Mera suggests to write limit, great Mera, e to the t squared minus ct. So she took the denominator up and changed the sign when t tends to infinity. Yes, now what should I do? You are right. This is the first step for my solution. Now you need to find the limit of the up here, the power, sorry. So you have infinity minus infinity. Also, unfortunately, infinity minus infinity undetermined. I can decide. But I have rule here. The rule said if you have polynomial and you need to find the limit when t tends to infinity, take only the highest power. So I have limit of e to the t squared when t tends to infinity equal e to the infinity, which is infinity. So my function, which is e to the t squared, is not of exponential order. because the answer is infinity. And also for me to find this limit, I notice my numerator e to the t squared and denominator e to the t. Which one is faster and will arrive to infinity? Which one is faster and will arrive to infinity first?
The e to the t square.
This one is faster. So your numerator will arrive to infinity first. So the answer of this limit is infinity. Second problem. I need to find the limit. Let me use another color. Limit of t squared over e to the ct. So I need you to check if the function t squared of exponential order or no. So you need to choose this limit when t tends to infinity. Can anyone help? Can anyone help? What do you think about the limits? I think it's very easy for you. It should be very easy.
L'Hopital?
L'Hopital. How many times do I need to use L'Hopital?
2 times.
2 times. So limit 2t divided c e to the t when t tends to infinity equal limit 2 divided c squared e to the ct when your t tends to infinity. So equal 2 over infinity, which is 0. So yes, that will give me my function t squared is of exponential order. And also for me, I can do the following. Check your numerator and your denominator. T squared and e to the ct. For me, the denominator is faster. The exponential is very fast. So this one will arrive to infinity first. So I have number divided infinity will give me 0. Okay, let me check or solve the last one now, which is give me 3 minutes only. I need 3 minutes. The e to the t times cosine. So you need to find limit of e to the t times cosine t, all divided e to the ct. My function now, it is my numerator when t tends to infinity. What should I do? What should I do now? Can I take the t down, e to the t down to be negative? So I have limit cosine t divided e to the t c minus 1 when t tends to infinity. I need help now. If c greater than 1 or c less than 1, what do you think? If your c greater than 1, your c greater than 1, so your denominator, it will be what? If c greater than 1, when t tends to infinity.
Positive.
Positive. So you have infinity. Am I right? And your
Yes.
numerator, cosine infinity. Cosine infinity divided infinity, as Bailey said, the cosine, it is number between -1 and 1. So I have only 0. What do you think if c less than 1? So c less than 1, so you have negative. So you have your denominator to be 0. Cosine infinity. It's number divided 0, cosine infinity. Number divided 0, it's infinity. So in this case, yes, of exponential order. In this case, no, it isn't of exponential order. Okay? Is it clear? What I need you to do is to check this function, please. And I have last slide now. Just give me 1 minute. Where is my bin? Where is my bin? Yes, this one. So I need you to do this. Check if this function of exponential order or no, and send it to me on WhatsApp as a private message. And last slide now, I'm going to explain the theorem here. Sufficient, notice it is sufficient condition. So if your function satisfies the following conditions, you can say, yes, there is Laplace transform. But if your function isn't satisfy one of the following conditions, you can't say anything. The theorem will fail. The conditions, my function f is piecewise, this is the first condition. Exponential order, this is the second condition. then Laplace transform exists. So two conditions, if both of them are satisfied, then you can say, yes, there is Laplace transform. But if one of them isn't satisfied, maybe this one, you can't say anything. And also, if the function isn't of exponential order, you can't say anything. So, Professor, if my function isn't piecewise, how to decide that this function has Laplace transform or no? Anyone have an idea? If the function doesn't satisfy the condition of this theorem, what should I do to check if the function has Laplace transform or no? Can anyone say anything? How to know if the function has Laplace transform or no? You have to evaluate the integral from negative infinity to infinity, your function times exponential function. And if you get the specific number, finite one, so you will say, yes, there is Laplace transform. But if your answer is infinity and your integral diverges, so no Laplace transform. Let us check this. This function is piecewise. This function is piecewise continuous. Okay. What do you think about of exponential order? I don't know. Let me check. So I'm going to take my function divided e to the ct and take the limit when the t tends to infinity. Can anyone give me the answer? It's very easy, by the way. Here root t, but here it is t. What do you think? What do you think here? Which one is faster? Which one is faster? Up or down?
Down.
Down. So here you have infinity and here you have a specific number. So it is 0 because my denominator will arrive to infinity before my numerator. So the answer is 0. So this function is piecewise and of exponential order. So I can say, yes, this function has Laplace transform. Okay. But if one of those conditions isn't satisfied, you can't say anything and you should go to your integral and evaluate it. So do you have any question? Anyone, if you have a question? We can meet at 1 o'clock to do the worksheet together if you need, if you have any difficulties. And if you have any question also, we can meet at 1 o'clock. And if no questions, I hope you have a nice day.
Doctor, I have a question on the midterm.
Yeah, I'm going to stop recording and wait me 1 minute. Other students, do you have any question?
Doctor, would you like us to write our names?
Actually, I forget to ask the first